Welcome to VK Lectures. In this video, we are discussing the question number 63 from KSET Physics question paper. Which of the following statements are correct regarding phase transition? Three statements are there. Let us look into the statements one by one. The statement 1 is phase transition takes place under isobaric isothermal condition. Now, phase transition means from either solid to liquid or from liquid to gas. So this transition, in this transition we understand that there is coexistence of phases. There is that means all the phases when you transition takes place from solid to liquid, that transition has the existence of two phases together. Existence phases, or you call it as coexistence of phases or multiple phases during the transition. Okay, now for that, Gibbs free energy remains constant. This is what happens in phase transition, where Gibbs free energy will be constant. Some examples we can take: melting means from solid to liquid, or condensation, this is from vapor to liquid. Now these two things occur at constant pressure and constant temperature. Now this is what we are going to show now, how it is at constant pressure. Constant pressure means isobaric. Constant temperature means isothermal. Okay, now let's write the formula, that is dG, that is the change in Gibbs free energy, is equal to VdP minus SdT. So this is the formula that we need to understand for phase transition. So change in Gibbs free energy is equal to VdP minus SdT. Okay, for any transition. Okay, now we know that this Gibbs free energy, or G, should be constant. Now G to be constant, dG should be equal to 0. Change in Gibbs free energy should be equal to 0. Now the right hand side of this equation 1, becomes 0. So 0 equal to VdP minus SdT. Now in this, if the left hand side has to be 0, VdP must be equal to SdT. Now for that condition, since V is not equal to 0, similarly S is not equal to 0. Both V and S are non-zero values, which means, and is also positive. V will be positive and S also will be positive. Okay, so both are positive values, and dP and dt, what is this? dP and dt, so they must be 0 because V and S are non-zero values. So dP equal to 0, which implies isobaric, that means constant pressure, and dt equal to 0 implies isothermal, which is constant temperature. So the statement 1 is a correct statement. Coming to the second statement, in the first order phase transition, volume and entropy remain constant. Now, what happens in first order phase transition? Let us take an example and understand. Example is ice melting to liquid. So ice, this is having higher volume, and it when comes to liquid form, it is having lower volume. The concept is simple. The ice is having lower density compared to water. Okay, lower density, and liquid is at higher density. So I think this is clear. That's why ice floats on water. Okay, fine. Now when there is change in volume, so it's a lower volume, so there is change in volume. So we have to understand that there is change in volume exists when there is first order phase transition. Now coming to the entropy. Now to understand this, entropy change, okay, so there is, we don't know whether it is constant or not. So entropy change, any first order phase transition. So let's start with first order phase transition. First order phase transition. So for every first order phase transition, there is involvement of latent heat. Latent heat is involved. Either it moves from solid to liquid, or liquid to gas. There is latent heat, either vaporization or fission, it is involved. Okay, now what is that given by? So L is equal to T times delta S. That means latent heat which is involved is given by T times delta S. T, that is the constant temperature, times delta S. Now there is latent heat means this value is positive or non-zero. So if this value has to be non-zero, both T and delta has to be non-zero. So if delta S is equal to positive or non-zero, S is not constant. If S is constant, delta S will be 0. So S is not constant, it varies, so delta S is positive. Which means what? Entropy changes. So both entropy and volume changes in first order phase transition. So the statement that is in first order phase transition, volume and entropy remain constant, it's a wrong statement. Now coming to the third statement, that is in second order phase transition, Gibbs function remains constant. Now let's say write down the formula dg equal to vdp minus sdt. Now looking into this, let's take the first order derivatives. So minus dou G divided by, let's take the temperature first, dou T at constant pressure, minus dou G by dou T at constant pressure should give us entropy. Similarly, dou G, now let us take pressure, dou P at constant temperature should give us the volume. So this is the first derivatives. So these are first derivative of Gibbs function. So first derivative of Gibbs function, both are positive values, they exist, and these are first derivative, and they are continuous. Okay, now if this is continuous, then Gibbs function also should be continuous. Now once we can write Gibbs function as continuous, Gibbs in the phase 1, Gibbs function in the phase 1 will be equal to Gibbs function in the phase 2. Okay. Now here we need to understand that second derivative, like for example heat capacity and compressibility. Compressibility are discontinuous. What is heat capacity? Heat capacity is nothing but the first derivative of the entropy. So that is dou S by dou T at constant pressure, and compressibility dou V by dou P at constant temperature. Compression, volume with respect to pressure, entropy with respect to temperature derivative is the heat capacity. You can write Cp. This is compressibility. Now here is a general information regarding the different orders of transition. So let's start with the first one, the first order phase transition. The first derivative of Gibbs free energy are discontinuous. First derivative of Gibbs free energy. Now what are the discontinuous quantity? One is entropy and another is volume. They change. So first derivative itself change. So first derivative, if it is changing, then it is first order. Latent heat is present, example melting, boiling, sublimation, etc. Now the second order. In second order, first derivative is continuous, that means it is constant, but the second derivative becomes discontinuous. So second order, when it becomes discontinuous, it is second order phase transition. First order, when it changes, it is first order transition. When first order is constant and second order changes, it is second order transition. The quantity that changes, So when it changes, we must know what is that quantity. Heat capacity and compressibility, they show changes. And what happens to the entropy and volume? Entropy and volume are the first derivative. They change smoothly or they remain constant. There is no latent heat present, absence of latent heat. Examples are superconductivity, ferromagnetism at Curie point, and superfluid nature of helium. Now, the third one is third order or higher. Higher derivative of G are discontinuous. That means first and the second are continuous, while the higher order, the third order derivative is discontinuous. Specific heat and other functions may exhibit subtle anomalies. Anomalies means change. Again, the latent heat is absent. In helium, the lambda transition is the example. So, according to the question, phase transition takes place. Yes, this is true. First order phase transition, volume and entropy remain constant. No, they change. In second order phase transition, Gibbs function remains constant. Yes, this is true. Now, 1 and 3 are the only correct answer. The option is option 2, 1 and 3 only. And in answer key, final answer key, it is shown as fourth option, but that is not true. It's a second one, 1 and 3.